For page 26 of your interactive notebook, we're going to be solving quadratic equations by using the quadratic formula. You should remember the quadratic formula from your Algebra 1 days, so some of this will be review for you. A couple things may or may not be. So your foldable is going to end up looking like this when you're done with it. However, it will, when you open it up, it'll look like this and it'll look like this. So just get it so that it's pasted on there. You can fold your tabs down. It's going to look like a diamond in the end. Go ahead and label each of your tabs. The top left-hand tab, when you fold it down, is going to be when the discriminant is what the discriminant actually is, which is b squared minus 4ac. I'm going to give an example of what happens when the discriminant is equal to 0. That's the top right-hand tab. There'll be another example at the top left-hand tab for when the discriminant is bigger than 0 or positive. And then the bottom right-hand tab is going to be for when the discriminant is less than 0 or negative. There's a note down here. It says you must have the equation in standard form, which is ax squared plus bx plus c equal to 0, before you're able to use the quadratic formula to solve a quadratic equation. So when we open up the top left-hand tab, this is talking about what the discriminant is and what the quadratic formula is. So the quadratic formula from your Algebra 1 days is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And I've highlighted and color-coded the discriminant. It's blue. That's what's under the radical here, b squared minus 4ac. That's considered your discriminant. It says, how does the discriminant work? So there are three possible things that can happen to that radical for your discriminant. It can be positive, it could be negative, it could be 0, or it could be negative. If it's positive, you'll have two real solutions. It's going to be rational. Both of them will be if you have a perfect square under there. But it'll be irrational if you do not have a perfect square. You'll still have two solutions. They'll just both be irrational. If it's 0, you have one rational solution because you'll be adding and subtracting 0 onto your negative b. And then if it's negative, you're going to have two imaginary solutions. So let's do an example. We have that is 6x squared plus x minus 15 is equal to 0. We want to solve for this. We know what a, b, and c are. And so we'll start with the discriminant. And so in this case, the discriminant is going to be b squared minus 4ac. So when you do that, b squared is going to be 1 squared minus 4 times 6, which is my a, times c, which is my negative 15. If you put this into your calculator, you'll end up with 361. This value is positive, so we know that we're going to have two solutions. And so it falls into this case right here. Now, 361 is a perfect square, so the square root of 361 is going to be 19. Now I have negative 1 plus or minus 19, all divided by 12. And so from here, when I do negative 1 plus 19, I'll get positive 18 divided by 12. And that'll reduce when I divide both top and bottom by 6. It'll reduce down to 3/2, positive 3/2. That's my first rational answer. Then if I do negative 1 minus 19, I'll get negative 20, divide by 12. Divide both top and bottom by 4 this time, and you'll end up with negative 5 divided by 3. And this is my second rational solution. What this means, we already talked about that. We talked about this part already. And so what that means is on a graph, you'll have two x-intercepts, one of them at negative 5/3, and then the other one at positive 3/2. On the next tab, top right-hand corner now, we're going to look at this next example. So this time we have that a is equal to 1, b is equal to 10, and c equals 25. So my discriminant then, when I put those letters in, is going to look like this. So I have 10 squared minus 4 times 1 times 25. I'll get 100 minus 100, which becomes 0. And so my solution is going to be x is equal to negative 10 plus or minus square root of 0 over 2 times 1. And my answer is x equals negative 5. Well, this time you'll notice that the discriminant is equal to 0, and we only end up with one solution because you'll have negative 10 plus 0 and negative 10 minus 0, both divided by 2. Well, those are going to be the same solution of negative 5. So what this means is I have one x-intercept, and it's going to be at x equals negative 5. That means the vertex is actually on the x-axis, and that's why you only end up with one solution. And then the last one, This is already in standard form, and it's set equal to 0, so I can go ahead and begin. A, B, and C. We'll plug those into my formula, b squared minus 4ac, to check out my discriminant. That's 2 squared minus 4 times 1 times 5. When I simplify that, it becomes 4 minus 20, which is negative 16, but this is less than 0, so I know I'm going to have two imaginary solutions. So when I plug that into my quadratic formula, I have negative 2 plus or minus the square root of negative 16 divided by 2 times 1. The square root of negative 16 is just simply 4i, so I have negative 2 plus or minus 4i divided by 2. Since all three of these numbers are divisible by 2, I'll go ahead and simplify that. That'll be negative 1 plus or minus 2i. So what that means on a graph is that because there are two imaginary solutions, that I will have no x-intercepts. I did plot my y-intercept of 0, 5, and then I have a parabola pointing upwards, but it will never touch this x-axis here. And that's all for this page.